Good morning. Today I'm going to go over assignment number 12. That's the cruise from San Pedro to Newport, down to Catalina, and back to San Pedro. So it's a 3-day cruise, and each day we have some different challenges on our routing or our plotting. So let's get started. Okay, so for day 1, they tell us to plot a course from LA buoy 6 to the Newport NWP buoy. So buoy 6 is on the LA side of the harbor. This is the Long Beach side. This is the LA San Pedro side. So buoy 6 is going to be this buoy right here, and we can check the longitude. That's a quick way to make sure we have the correct buoy. And then we're going to go all the way down to Newport and our safe watermark, our NWP safe watermark. So we're going to connect those 2 points and draw a line. So I like to put my triangles like this and connect those 2 points. And then when I draw my line, I always draw it on the same triangle. So I draw my line, and then I move my triangle down, and then I draw my line again. So it's always drawing it on the same triangle. Okay, so I've connected the 2 buoys, buoy 6 and our NWP buoy, and I've drawn the line. Our first step is to get what the true course is of that line. So I'm going to use both the roll plotter and the triangle. First I'll show you on the triangle. You can use any meridian. It crosses through this meridian and this meridian. Either one works. It's a straight line. This one's a little more clear, so I'm going to use this one. So you want to put, I like to use the black line. You can use the edge. I just like to use the black line because I feel like it gets a little bit clearer picture. And then the focal point on the meridian. And then we could read down at the bottom what our angle is. So let me zoom in on that. So using the triangle, I have this black line on the line that I drew connecting the 2 buoys. Then I have the focal point on this meridian, and then I could read at the bottom that this is, so this one right here is 110, this would be 115, this would be 120. So where the bottom of the meridian passes through on the triangle is 111. So that would be the direction of this course. 111. Okay, so now let's do it with the roll plotter. With the roll plotter, we put the edge or the black line on the line in question. So we line it up there. Let me see that. And then you bring it to the compass rose. This is the closest compass rose, and you bring it to the center. I'm just going to put my pencil there on the center, and then I can draw a line. And we always are looking for the outside. So we have 90, 95, 100, 105, 110, and a little bit. So 110 would be our true course. Now we can draw that. I just simplified it on the whiteboard so we can see it a little clearer. For our course of 111 degrees true at a speed of 5.5 knots. Okay, we are leaving this buoy at 12:40. So we want to put a DR at the top of the hour at 1300 and every hour so forth until we get to our NWP buoy. So let's practice our DRs. Okay, to plot our DRs, we first need to plot to 1300. So we need to figure out how long that is. So we have 1300 minus 1240. That would be 20 minutes. So we have a time of 20 minutes. Our distance is our question mark, and our speed is 5.5 knots. So we'll plug that into our 60 D Street calculation. And we're looking for distance, so we have D equals speed times time over 60. We have the distance to equal 5.5 times 20 divided by 60. So I'm going to plug that in. We have 5.5 times 20 divided by 60. And that equals a distance of 1.8 nautical miles. So I'm going to find my 1.8 nautical miles using my dividers. So I have here a distance of 1.8 nautical miles, and I am going to draw in my first DR. So from my buoy, I can draw in and label this point a DR, which is that half circle, and we can call it 1300. So that distance there was 1.8 nautical miles. In order to get our next DRs, we want them to continue on the hour. So if our speed is 5.5 knots, that means we will travel 5.5 nautical miles per hour. So in 1 hour, we'll travel 5.5 nautical miles. So I'm going to get 5.5 So now I have a distance of 5.5, and from my 1300 position, so I start at my 1300, and I can mark a 1400 position, a 1500 position, a 1600 position, and I can't go past that for the hours. So let me do that on the whiteboard for us. So our distance between our DRs is our speed which is 5.5 nautical miles. One part of the question was what is the total distance of this entire leg? So I know it is very long, a foot or so, more than a foot. So I'm going to get 5 nautical miles, and I start at the buoy because I'm getting the total distance from buoy to buoy. So I start at the buoy and walk my way down. So here's my buoy, and we walk on the line. 5, 10, 15, 15 plus, adjust it here, so I have 15 plus 4.2 just shy of 5, so 4.4. So I have that 5, 10, 15, 4.4 gives me a distance of 19.4 nautical miles. That's the total distance. Our total distance was 19.4 nautical miles. It says to plot your DRs and label, which we've done. And then it asked us what is the position of our 1400 DR. So it was right next to that fishing haven. But to get, so I'll use the triangle. We want to get from our 1400 position, our DR position, the latitude and longitude. So I'm just going to make a line to the nearest meridian and latitude, big bold line. And then I can use my dividers to get my latitude and bring it over to read my latitude. So I have 33 degrees 39.3 minutes north. And then I can get my longitude. So distance from this meridian, bring it down. And I have 118 degrees 6.2 minutes west. So that's my position. And then it asked me, as we made our track line, do we see any possible hazards along the way? And down here we see a wreck that we want to be careful of. So that is going to be our hazard, and we want to see what the position of that hazard is. So again, I get the longitude, and latitude is right next to it. So I just call it really 1/10 of a minute, 2/10 of a minute. So that would be for latitude. Bring it over. And we get 37.5. So 33 degrees 37.5 north. And then we were just shy of our 118, so I have 117.59.8 minutes west. So those are just practicing getting our lat and longs real quick. And then it says, at 1400, you believe you might be off your track line. You observe 2 aids to navigation, the tank on Anaheim Bay in the Naval Weapons Station, and the oil platform EVA. So we have our Naval Weapons Station up here in Seal Beach, and we're going to use the tank, which is right above it. There's our tank. And then we're going to use the oil platform EVA. And these both happen to be 000, so due north, and 090, due west. So these are going to be pretty simple to plot. I'm going to put my pencil on the tank, and then using this line on my triangle, I know that that's perpendicular to a latitude line, so this would be due north and this would be due south, parallel to our meridians. So I could draw in a line. And then for my EVA platform, I know it is due west. So again, I'm going to put my triangle on a meridian, so I know I have due west and due east, and I could draw in my line. So where those two cross is my actual 1400 position. So this would be my 1400 position, and then they ask us to get the latitude and longitude. We already have a vertical line, so let's make sure this line goes all the way over. So we have a latitude of 39.7, so 33 degrees, 39.7. And our longitude of just past the 5, so we have 5.4, 1185.4 for degrees west for our longitude. So that's our actual 1400 position. So we thought we'd end up here, but we ended up here. That means we are drifting closer to shore. So we might want to be concerned, or not concerned, but aware of the fact that we are drifting closer to shore. So, are you to the left or right of track, or off track? Yes, and we are to the left of track. So if we want to go back on track line, we just have to steer to the right. So we just correct which way. What course do you recommend to get back to our NWP buoy? So from our 1400, we're going to draw a new track line to our NWP buoy. So let's draw that in. And it will just barely reach on the triangle. So my buoy to my 1400. I'm going to put it on our whiteboard as well. So I have my 1400 position, and we drew a line from our 14 position to the buoy. So we've drawn a new track line. And then it asks, what is the course of our new track line, and what is our new ETA? So I want to get the course. My speed is still 5.5. And what is my new ETA to the buoy? Using the triangle first, I can line up the new track line and the meridian on the triangle, and I get a new reading here to be, this is 110, 120, so I get my new reading to be 114 degrees. So I'm steering further to the right, but that's just to get to the buoy. So my new reading is 114. I can also use it with my roll plotter or parallel rule. Line it up on the new line, and then bring it down to the center of our compass rose and draw in our line. So we have a slightly to the right of our original line. So now we have a course of 114 degrees true, and it asks us what is our new ETA. So for a new ETA, we need distance, speed, and time. We're looking for an ETA, so time is our question mark. Speed is our 5.5, and distance we need to measure. What is the distance of the remainder of our leg? So our distance is pretty far, so I'm going to start with a 5. So I have 5, start on my 1400, we have 5, 10, 10 plus 1.6, so that would be a distance of 11.6 nautical miles. And now I can plug this in to my 60D street. I'm going to try the magic circle this time. We have 60 times 11.6 divided by 5.5. We have a time of 126 minutes. So that would equal 2 hours and 6 minutes. If we started at 1400, it would take us 2 hours and 6 minutes. So our new ETA would be 16:06. And that is day 1 of assignment 12. So let's move to day 2. Alright, so on day 2, we go from the NWP buoy in Newport to White Cove. We're anchoring in White Cove, which is just south of Long Point, and we're aiming for the little rock. So we're going to draw a straight line. From one buoy to White Cove. And again, we always draw on the same triangle. So we can draw our line, move the triangle down, continue to draw our line, move the triangle, and continue to draw the line. So we have our new track line, and we depart NWP at 11:30, and we're going at a speed of 6.5 knots. What is the true course, and what is the course to steer? So since we have our line, we have it crossing this meridian, and this meridian. So on any of those meridians, we can use our triangle or roll plotter. If we use the roll plotter, we can line it up on the line and then bring it down to the compass rose, and we get a true course of 245. If we use the triangle, we can put our triangle line on the line in question, focal point on meridian, and then read at the bottom in between 240 and 250. So we have a course of 245. So we simplify it a little on our whiteboard. We have a course of 245 degrees true. Now they also asked what was our course per standard compass. So now we have to convert that true into a compass course. So we use our TVMDC plus west minus east. We start with 245 degrees true. Variation is found on our compass rose. So variation is 12 east. It's east, so we are going to be subtracting it. And we get a magnetic of 233. Deviation, we use deviation table. So we're looking for a magnetic heading of 233. We have in between 229 and 235 a deviation of 7 west. So we could say 7 west, and because it's west, we'll be adding that. And we have our compass course of 240 degrees PSC. So we could write that in as well. I guess I'll write it up here. And I have a speed of 6.5 knots. Okay, the next question is what the total distance is. So this is long, so we're going to have to walk our way through. So let me get 5 on my dividers. So we start at the NWP buoy. We have 5, 10, 15, 20, 25, 25 plus 2. So we have 27 as our total distance. Alright, we have our total distance of 27 nautical miles. Our next task is to plot our DR positions. So we left our NWP buoy at 11:30. So we need to put a DR for every hour. So we need to go to the top of the hour and then every hour from there. So we have 30 minutes we need to get to noon. So if our distance is what we're looking for, our speed is 6.5, our time is 30 minutes. We can go do the magic circle. So we have 60, question mark, 6.5, and 30. So we'll plug that into the calculator. The two things we have, we multiply 6.5 times 30, and then we divide by the last number, divide by 60. So 3.25 is our distance, and that is where we'll put our first DR position. Okay, I just cleaned this up a bit. So to our first DR, we have a distance of 3.25, and that gets us to noon. Then we have on the hour, on the top of the hours. Our speed was 6.5, so our 6.5 nautical miles per hour to the top of the hour. So we have 6.5 to get us to 1300. Another 6.5 to get us to 1400. And another 6.5 to get us to 1500. So now we have our DRs. The next few questions talk about ETAs. So they want to know what the ETA is when we enter the traffic lanes, when we exit the traffic lanes, and what our ETA is to White's Cove. So just by looking at this, I know we are going to enter the traffic lane past 1300 and maybe in the middle or a little bit shy of the middle. So maybe 1330, 1320, something like that. When am I going to exit the traffic lane? Just after 1400, maybe 1415, 1410, something like that, just as a rough estimate. When am I going to get there? Not quite 1600, so maybe 1645 or 1650, something before 1600. So just from this, I can give a rough estimate, and in most cases, a rough estimate is completely fine that we can go with. But because this is an exercise of 60D Street, we can calculate exactly what our ETAs are. So let me get rid of these and I'll show you how to do the ETAs. Alright? Okay, now that we have our DRs, it asks us what is the position of our 12 o'clock DR. So we're going to get the latitude and longitude of that. And then it also asks what is the depth at our 1200 DR. The depth soundings look something like this. Okay, so if I zoom in a little bit on this sounding point of our 12 o'clock DR, I have this fathom line moving along. My track line crosses it, and exactly right here is my 1200 DR. So this line tells us something. And if we follow it all the way towards here, which is right there, it tells us 150. So there's 150 fathoms everywhere along this line. And because our position is right on that line, our depth is 150 fathoms. Anything closer to shore from that line is less than 150 fathoms. Anything further from shore is deeper than 150 fathoms. So that answers 14. And 15 asks us what is the ETA to our final destination in White's Cove. So we had calculated our distance from NWP to White Cove to be 27 nautical miles. We know our speed is 6.5. How long will it take us? So we go to our 60D Street. I'll do the Formula 1 this time. So we have 60 times D divided by S gives us T. We have 60 times 27 divided by 6.5 gives us T. So we'll plug that into our calculator. For 60 times 27 divided by 6.5, we get 249 minutes. Now we need to convert that to hours and minutes. So we can either subtract 60 until we get a number that's under 60, or we can divide that number by 60, and we get 4 hours, 0.15 number. So in order to convert that back to minutes, I subtract the whole hour. So I'm going to subtract 4, and I'm left with just the decimal portion, and then I multiply that by 60 to put it back into minutes. So I'm left with 4 hours and 9 minutes. So now I can do my adding and subtracting. If I left NWP at 11:30, and it took me 4 hours and 9 minutes. When will I get to White's Cove? I always do the minutes first, so I'm left with 39. And then I can do the hours, and I'm left with 15:39. So my ETA to White's Cove is 15:39, which would make sense with my DRs. It's past 1500, but not quite to 1600. So we have our ETA to White's Cove. Now we're going to figure out a few more ETAs. Okay, so our next few questions ask us about the ETAs, entering the traffic lane and exiting the traffic lane. That's when we want to be alert for bigger traffic in the area and give them the right of way if they are using the traffic lane and we are crossing it. So if we are sure that we have calculated our 1300 DR position correctly, we can just measure from our 1300 position to make our math a little bit easier to figure out that distance and create an ETA for entering and exiting. So let's do that. I'll do it on the whiteboard, make it a little simpler for us. So our distance between our 1300 and entering the traffic lane is 2.9 nautical miles. And I'm just going to get the distance for exiting the traffic lane as well. So and that was 0.4. So that distance is 0.4. So let's convert those into time so we can get our ETAs. So we're looking for time. We have our distance of 2.9, our speed of 6.5, and our time is our question mark. So we have the magic circle. So we can go to the calculator and do 60 times 2.9 divided by 6.5, and that gives us approximately 27 minutes. So our ETA to entering would be 13:27. Now to do the exiting of the traffic lanes, we can do the same calculation. Distance would be 0.4. Speed is 6.5. Time is our question mark. Back to our calculator. We have 60 times 0.4 divided by 6.5 . Back to the calculator. 60 times 0.4 divided by 6.5 gives us 3.69, so about 4 minutes. So we will be exiting the traffic lane at 14:04. So that is how we got our ETAs for exiting and entering the traffic lanes. Okay, so our next question talks about as we are traveling down, we pass the traffic lanes, and we want to get a final position before heading into White Cove. So it asks us that we think we should be able to see Santa Catalina East End light. That is this light down here, and it asks us why can't we see it? Well, this light is obscured because of the land around it. So it is obscured and it gives us this line of a visual range, so kind of like a vector light, that if we are anywhere north of this, we are not going to see this bright light. So that is why we can't see it. We are somewhere up here traveling to White's Cove, so we won't be able to see it the entire time. So at 1500, we take a final fix before heading into White Cove. We have Long Point bearing 262 degrees true, and we have the tank at Pebbly Beach bearing 214 degrees true. So we want to plot both of those. So I'm going to show you with the triangle and then show you with the roll plotter. First we want to locate Long Point light is here, and the tank at Pebbly Beach, which is N of 2, that's north of 2, is down here, right on that latitude line, 20 minutes. So not to be confused with the one a little bit further north of it. So first I'll get my Long Point. I'm going to put my pencil on Long Point, so I have something to pivot on. Move that out of the way. And I am looking for 262. So I'm going to move my my triangle around until I could find 262. There we go. So I have my focal point on the meridian and then 262 crossing the meridian. There's a lot of little lines there, so it's a little hard to see. And of course, if it's too hard to see there, we can flip it over. It's a little bit clearer on this side. So we can find, oh, you can't see it. Okay, there we go. Crossing the meridian and then 262 on the top end of the triangle, and my pencil on Long Point. So then I can push down and draw in my line of position. So that was for Long Point. And then I have north of 2, the tank at 214. In this case, I'm going to, instead of putting my pencil on it, I'll be pretty far away, so I'm going to be moving it over, and I wanted to show you guys how I did that. So I'm going to find, let's do it like this again, just so you can see it clearer. 214, so I'm going to, anywhere on this meridian, and I'm just using the parts with the white background so it's easier to see. The focal point on the line, and then 14. So 214 is going to be right here. So I have 210, 220, so 214, and the focal point on the meridian. Now in order to move it, you use the short sides of the triangle. So you bump up your straight edge against the short side. In this case, I want to move it in this direction towards north of 2, the tank, Pebbly Beach. So I'm going to put my straight edge on the top short side of the triangle. And then I have my pressure on the ruler. and I could just move it on over to where it hits the tank. Then I can draw in my line. And of course, we have the compass rose here. So if you're using roll plotter, you can look for 262. So I could find 262 on the compass rose, and then just parallel that up to long point and draw in my line. And if you're using the roll plotters, I'll do it for the next one here at 214. You find where 214 is, right about there. And Pebbly Beach is over my ruler, right? It's underneath. So you have to move it out of the way and then line it up and draw in your line of position. So that was using all three different tools. But we have our 1500 position, and in the last 3-4 hours, we have drifted off our track line quite a bit. We are quite a bit off from our 1500 position. So it asks us, what is the new course to go into White Cove from our actual 1500 position? So you just draw in from your 1500 position your new track line, and then you want to get the course, the true course, of course. So it crosses the meridian, so I just line it up there, and I can read this is 250, this is 260, so it would be 256 as my true. So my true bearing, or my true course to White Cove is 256 degrees, and I need to convert that to my compass course. So what was my compass course to steer? So I have TV, MDC, add west, minus east, and I could plug in my numbers. Variation we get from the compass rose, that's 12 east. It's east, so we're going to be subtracting it. So we subtract and get 244. We go to our deviation table, and at 244 we get a deviation of 8 degrees west. Because it's west, we're going to be adding. So we get our final compass course of 252 degrees PSC. So that would be our course to steer. And then it also asks us how far away are we from our anchoring position at White Cove. So we just use our dividers. And measure our distance. I have 6.8 nautical miles. So our distance to go is 6.8, and we have our new course to steer. So that's it for day 2. Now we're going to move on to day 3. Okay, so on day 3 of our cruise here, we get up. It says in the morning, you get underway early and you sail along the coast of Catalina without really taking any fixes. You're just enjoying a nice sail. And then the wind comes up early afternoon, and you want to take a fix so you know where you are before heading back to LA, Long Beach, wherever you're going. So at 1412, we got the bearings for Santa Catalina West End Light and Ship Rock. So we got those two bearings, and we want to figure out where we are using those two visual bearings. So our first one is West End Light, and it was bearing 265. So I'm going to find, put my pencil on West End Light, put my focal point on the meridian, and then 265. So I have 265 there. And I can draw in my bearing. So I am somewhere along that line, and I could see from the obscuredness, I just barely saw that light. And then I have Ship Rock at 202. I'm going to put my pencil on that, get my meridian here. So I have my focal point on the meridian, and then 202. So I can draw in my LOP, and where those two LOPs meet, that is my position at 1412. So again, I can do that with a roll plotter. I guess you can see this one would be hard to use because they're both pretty westerly, but there is one up here you can get to for our 262, and then just bring it down and plot it. And then same with our 202, somewhere around there. And you can just bring it over to Ship Rock and plot it there. So there is a compass rose that we can use for using the roll plotter. So it asks us what is the position. So I always like to get my position. And with this one, we are very close. We can also use the parallel ruler to just bring it down and read what our position is. So we have a position of 33 degrees, 29.123. And then for longitude, let's see, does it reach this? It would barely reach. Let's try it. So nice and straight on our meridians, and then roll it over and bring it down. Oh, you can't see. Bummer. We get 118.28 for our position. And then it asks us, it's been a great cruise, so we take down our sails and we set our RPMs to 5 knots, and we head straight back to the LA entrance, to buoy 3. So let me reposition the camera here to see buoy 3. Okay, so buoy 3 for the LA entrance is right here. And we're going to go from our 1400 position to buoy 3. So our first step is to just connect the lines. I'm going to do that with a yardstick, just to make it a little easier right here. So our first step is to measure the course to get to buoy 3. So I'm going to use a triangle first. It really only crosses one meridian, so I'm going to use this meridian. And I line up the black line on my course line that I drew in, and the focal point, and I get a course of 045. 045 degrees true. I can also get that with a roll plotter, line it up, and bring it up to the compass, and I can get 045 on my compass. But the question is, what do I need to steer per ship's compass? So I need to convert this. So I get variation from the chart, and I have 12 east. And it's east, so I'm going to be subtracting it. And I get 0.33. Deviation I get from my deviation table, and I had a magnetic of 3.3, so I would get a deviation of 3 east, and that's east, so I'd be subtracting it again, and I get a compass of 030 PSC. So I could write in, I have a course of 045 degrees true and 030 degrees PSC. So, and I'm going at a speed of 5 knots. So now it asks me, what is the distance of this lake? Again, this is a long lake, so I'll need to walk my dividers. I get 5 on my dividers, so I have 5, 10, 15, 15 plus 2. So 17. I have a, let's see here, distance of 17 nautical miles. So that was question 24. 25 is, what is the position when you enter the southbound traffic lane? So this traffic lane up here kind of has this dog leg where it comes down and then we enter the traffic lane right before the dog leg. So right here is when we enter the traffic lane, and then here is where we would be exiting the traffic lane. Of course, we'd have more and more traffic the closer we get to the harbor. So to get that position, I get a position of 35.6 or 7. And then for longitude, I get a longitude of, what is this? 118.21.2 for my position there. And then it says, so that was just gathering some information. And then it said at 1500 you increased your speed to 7.2 knots. What is your new ETA? So we didn't calculate our ETA yet, but we're going to have a new ETA because we have to change the speed. So we get new DRs every time we change speed. So let's do that. We left here this was our position at 1412, and at 1500 we changed speed, but it didn't give us a position. So we need to DR where 1500 is so we can see where we increased our speed. So we need to do our 60 D Street so we can get a 1500 DR position. Minus 12 gives us 48 minutes. So we have a time of 48. We have a speed of 5, and we are looking for our distance. So we can go to D equals S times T over 60. Distance is 5 times 48 divided by 60. We have 5 times 48 divided by 60. We have 4 nautical miles. So, 4 nautical miles to our 1500 DR. We get 4 nautical miles. So from our 1400 position, we mark where our 4 nautical miles are, and we say this is where we will be. I'm going to erase this. A little less confusing for us. So this is where we're going to be at 1500. And that's where we increase speed. So our course is still 045, but now our speed changes to 7.2. Okay, so we have our new 1500 position, our 1500 DR position, and we have our course of 045 and our new speed of 7.2. Now it asks us what is our ETA to when we enter the traffic lanes. So to this point right here, so when we're going to be aware of entering those traffic lanes. So we get our distance, we measure our distance here. Get a distance of exactly 5. So we have a distance of 5, we have a speed of 7.2. How long will it take us to get there? So we have 60 D divided by S gives us T. 60 times 5 divided by 7.5 gives us T. Let's see how long that'll take us. 60 times 5 divided by 7.5 gives us 40 minutes is our time. And if that's 1500, our ETA would be 1540. And then it asks us what buoy must we be careful for on this course. So this one is a scavenger hunt, a searching one, and we get very close to this buoy in the separation zone of the traffic lane. It's hard to see because it's magenta on magenta. So it's the yellow 092 buoy that we are passing pretty close to. We're not running it over on our track line, but if we are to the right of track, we'll get very close to it. So we just have to be aware. Then it tells us at 1612, you're using a hand compass, and you see Point Vincent Light bearing 030 magnetic and Point Furman bearing 00 magnetic. What is your position using those bearings? So let me zoom in here on our Point Furman and Point Vicente. Okay, so we have Point Vicente here and Point Furman here, and we have our bearings using a handheld compass. So that means they come in as magnetic. We don't have any deviation for them. So they come in as magnetic, we still need to convert them to true. So to convert them to true, we need to apply our variation. Our variation is 12 east. We get that from the compass rose. And if we're going from C to T, or M to T, we're going to be adding east. So we have a true of 315, true, and a 012 degrees true. So those are our bearings from Point Vicente and Point Furman. So let's plot those. I'm going to find our 315 and move it over to Point Vicente just so it's a little easier. So we have 315 focal point on the meridian, and then 315 on the meridian. And then I'm going to move it over to Point Vicente. Moved it a little bit. There we go. So I'm going to move it over to Point Vicente, and remember we go from the solid dot, so we can draw in our line. So we're somewhere along that line, and then we have Point Furman at 012. So let's see if I can do Point Furman. Not quite, so I'll find 012. And then move it over there. So I have 012 at the top and my focal point. And then I put something against the small side, and I can move it down to Point Furman and draw in my line. So now I have right here where those two cross is my 1612 position. So I need to get the latitude and longitude. Bring it up here. And I get 118.18.4. And then here, bring it over, and I get 39.3. So 33 degrees, 39.3 for my position. And then they'll ask me from this position, what is my new course to my buoy 3? And what time should I get there? So I need to draw in my new course. So I have a new line, and again I'm just going to use the meridian. It doesn't cross through, but I can still get most of this line on the triangle. So you can still use it. And I have a true course. Oops, moved it. There we go. Just shy of 060. So 059 is my true course, but it asks me what it would be in compass course. So again, I need to convert. So I had my true course of 059. I'm going from T to C, so I'm going to be adding west, subtracting east. My variation is 12 east, so I'm going to be subtracting that, and I get 0.47. I go to my deviation table, and I have a magnetic of 0.47, and I get a deviation of 4 degrees east. And with 4 degrees east, I'm going to be subtracting that again, and I get a compass course of 0.43 degrees PSV. So that is my course. Oops. 0.43 degrees PSV. So that's my course, my new course, directly to buoy 3. And then it also asked me what my ETA was. So, in order to get ETA, we need the distance. We know our speed is 7.2. We're looking for our ETA, so we're looking for time. We need our distance. So let's get our distance here. I got 3.9 as my distance. Just for simplicity here, we'll do the 60D Street Magic Circle. So we have 60 times 3.9 divided by 7.2 gives me 32.5 minutes. So we'll call that, we'll just call that 33. So if I left that buoy or that fixed at 16:12, and it takes me 33 minutes to get to the buoy, my final ETA would be 16:45 for my final ETA to buoy 3. And that is it for our 3-day voyage. If you guys have any questions, please let me know. I'd be happy to go over them before class or during class. And for next week, we're going to learn 2 more types of position, and then do another voyage like this one. So I hope you guys have a good weekend, and take care. Thanks.